All right, so this is problem 4.23. I'm going to solve this problem using the universal method. So we want to find currents I1, I2, I3, and we want to verify that the power dissipated equals the power developed. So I'm going to go ahead and label each node. I'm going to call this node our bottom, or this bottom node our ground. This has a -30 potential. Here, let me show that. This node is unknown, we're going to call it V1, and then we know that this node here is 80 volts. Okay. So since we already have these currents labeled, we're going to call this current I4, and we call this one I6. We could call this label a variable for this current, but we already know, so there's no need. So yeah, let me go ahead and I'm going to write the KCL. We have I1 equals I4 plus I2 plus 10 milliamp. Then we have I4 plus 10 milliamp equals I6, I believe, or is this I6? I don't even know what I call it I5. For yeah, 5. So yeah, it would be I5 plus I3. Okay. Yeah. So we have I1 through I5 plus V1, so we should have 6 equations. So for EFC, I1 is equal to -30 minus V1 over 5,000. I2 equals V1 over 500. I4 equals V1 minus 80 over 1,000. I5 would be equal to 80 over 4,000. So I'm going to plug this into Maxima. And 6, we have 1 equals I4 plus I2 plus 10,000. Now run. I5, 3, 1 equals -30 minus V1 over 5,000. 2 equals V1 over 500. 4 equals 1 minus 80 over 1,000. 5 equals 80 over 4,000. And we have 1, I2, I3, I4, I5, and then V1. Okay, so this is what we get. Spam this, we get something clean. Okay, so now we gotta verify for power dissipation being equal to the power developed. Right, so we have all the space here. So P dis power 5K ohms. So we know I1 is 1/100 times 5,000. 500 ohm. You know that I2 is 1/25 squared times 500. So 1K, we know I4 is 3/50 squared times 1,000. We have 4K. I5 is 1/50 squared times 4,000. Okay. So I'm gonna calculate it really quick. 0.5 watts. 0.8 watts. So the sum of these is 1.6 plus 3.6 plus 0.8 plus 0.5. Right, so we have a total power dissipated of 6.5 watts. Now total power developed for the 30 volt. We have times I1 should be 0.3 watts. Power developed by the 10 milliamp source would be V1 minus 80. So we have -6. Well, these are all negative. We know these are positive. But anyways, 10/1000 times 60, 0.6, and then the power of the 80 volt source would be 80 times I3. 3 is 7/100. 80/100. It's 5.6. And the sum of this, 0.9 plus 5.6 is 6.5 watts. Okay, so yeah, we see that these two equal each other, and our values of I1, I2, and I3 are actually going in a reverse through. Oh, well, I1 and I2 are actually going in the opposite direction that is shown, and I2 stays the same. And yeah, that's a solution for 4.23.